Hello everyone. In last lecture, we saw the acidic strength we compared. Now we are solving remaining questions. See, in this question, we will solve some questions related to acidic strength. First, compare the acidic strength of benzoic acid, orthonitrobenzoic acid, metanitrobenzoic acid, and dianitrobenzoic acid. So in this case, see here benzoic acid is there. In this position, at ortho position, nitro group is present. In this case, at meta position, this is ortho, this is meta, this is para. Here, meta position, nitro group is present, and in this group, in this question, at para position, nitro group is present. So, for comparing the acidic strength of all these compounds, we have to first identify our acidic proton, and we have to identify the point of differences in all the compounds. In first, we will see that in all the compounds, acidic hydrogen is this which is directly attached to oxygen or which is the part of COH group. So when we will remove this H plus, when this proton is removed, we know that we will get a anion, which will be here this C double bond as it is, and here this H will be removed in the form of H plus and O minus will be formed. So I hope this is clear till now. So now I will not explain this in much details. Okay. So I hope you have understood how O minus is removing. So here also when this H plus is removed, O minus will be formed. And this is nitro group. For convenience, I am writing this in this elaborated form. Okay. Now, in third case also, when H plus is removed, we will get COO minus and nitro group at meta position. And in last case, we will get again anion and nitro group at para position. So now when we compare this, first of all, we know that nitro group is showing two effects. Which are those effects? So first effect is mesomeric effect and second effect is inductive. And we know whenever there is possibility of mesomeric effect, then we will take this group as prominent group and we will see we will give priority to mesomeric effect. So first of all, see, in all these compounds, nitro group is present. Therefore, in all these compounds, nitro group will act as electron withdrawing group because by mesomerism or by inductive, by both the effects, nitrogen will pull or nitro group will pull electron density. So therefore, when we consider about the stability of this O minus, we know this O minus will be stabilized if any electron withdrawing group is attached to this ring. So this ring will be when suppose in this case electron withdrawing group is attached to the ring, then that electron withdrawing group will pull electrons from the ring, making this ring electron deficient, and in turn this ring will pull electrons from this anion, making this anion more stable. Therefore, whenever there is electron withdrawing group present in the ring, that will be more stable anion and that compound will be more acidic. So from all these compounds, let us give them, mark them as A, B, C and D. So from all these compounds, we know that A is least acidic or stability. When we consider the stability of anion, so we know that A will be least because all are benzoic acids and here no electron withdrawing group is present, therefore it will be least. Now in all these compounds, we know that here nitro group is present at ortho position, here nitro group is present at meta position, and here nitro group is present at para position. And we know that at ortho position and at para position, nitro group shows mesomeric effect, that which will be negative mesomeric, it will withdraw electrons from ortho position and similarly from para position. And at meta position, it will not show mesomerism. Now, if you want to know how this resonance works, I have uploaded a short related this. So go through that short and see how nitrogen pulls electron density via mesomerism. Okay. So in short, you have to remember nitro group because see, when nitro group shows mesomerism, it will form a positive charge here, a positive charge here, and a positive charge here. Here means at the carbon adjacent to this carbon, which is directly attached to anion. Therefore, due to this positive, it will stabilize this anion, which is not the case in meta position. Okay. Therefore, nitro group will show resonance effect only at ortho and para position. Okay. Therefore, what will happen at these two positions? It will show negative mesomerism effect. Similarly, at all the positions, it will show inductive effect also. Okay, and which inductive effect? Because here positive charge is on nitrogen, therefore it will pull electron density from this carbon. Therefore, this carbon will pull electron density from this carbon. Therefore, this carbon will pull electron density from this carbon, and therefore this electron density on this oxygen will be reduced. So, therefore, that negative inductive effect is present in all the three compounds, but in ortho and para substituent, mesomerism effect is also present. So, here only inductive effect is present, and we know that mesomerism effect has more priority than inductive effect. Therefore, this will be less this inductive effect will stabilize this anion is in lesser quantity than ortho and para positions. Therefore, it will go to second position, second last. Okay. Now, when we compare ortho and para positions, see at ortho position, nitro group is closer to this center. Okay. Here, distance between anion and nitro group is lesser, but in para position, the distance is more. Therefore, here the extent of inductive effect will be lesser. Therefore, if inductive effect is less, then that anion will be less stable. Therefore, it will be less acidic. Therefore, stability of anion in ortho and para position will be such that para will be less stable than ortho. Ortho is weak. So, this will be the overall stability of anion. Now, acidic order will be, or acidic strength will be, if stability of anion is in this way, therefore, the order of acidic strength and stability of anion will be same, and therefore, this will be the acidic strength. Means, our benzoic acid, which has no substitution, will be least acidic, and our ortho substituted benzoic acid will be most acidic. I hope you understood this question. Next, our next question is, see, in this question we have to compare the acidic strengths of benzoic acid, benzyl alcohol, phenol, and parachlorobenzoic acid. So, previous questions we have seen, those were a little tricky questions, and these questions are simply very easy questions. See, because we know here benzoic acid is present, so here we can see the functional groups are different. Like here OH group, this is phenolic group. Okay, this is phenol. This is acid, carboxylic acid. Okay, this is also carboxylic acid, but it is not aromatic. This is aromatic carboxylic acid. Okay, and in this case, aromatic carboxylic acid is present, and with that electron withdrawing group is present. Okay, so we know that whenever acid is present in the comparison, always acid will be more acidic. Therefore, from the fourth compounds, phenol will be least acidic. Okay, acidic strength, in case of acidic strength, see, all three are carboxylic acids, means acids, and this compound is phenol. So obviously phenol will be least acidic as compared to remaining. If we give them numbers A, B, C, and D, so we know that C will be least acidic. Okay, C will be least acidic. Now we have to compare remaining compounds. So see, again we will have to form the, we will have to remove H plus, and we will have to form the anion. So this anion is forming when benzoic acid donates H plus. When benzyl alcohol, actually here benzyl alcohol should be there. I'm so sorry. Here benzyl alcohol. Okay, this is not acid, this is alcohol. Okay, so this is alcohol. It should be like this. So we know that phenol will, in comparison to phenol and alcohol, phenol will be more acidic. I will tell the reason, but phenol will be more acidic. So this will be least, and this is in more, and then we have to compare this. Okay, first let us see. So I hope you understood this. This is OH. Okay, so when H plus is, because here only this acidic H plus is present, so when we remove this H plus, we will get this anion. Okay, when we are removing this acidic H plus, we will get phenoxide anion. Okay, because this bond will break like this. Okay, and in last case, negative, we will get this compound, this anion, which is COO minus, and here para position chlorine, that electron withdrawing. This is electron withdrawing group is present. Okay. So now when we compare all those, we know that this is actually alcohol. So alcohol will be less stable first. The reason for this, that is, see, in this compound the anion form will be stabilized by inductive effect, because this is CH2 group. Okay, here ring is present, so here only inductive group is present. Here resonance effect is not present. Therefore, if we see inductive effect of CH2 group, it is donating, right? So it will not stabilize this anion. Therefore, here only inductive effect is present. Inductive effect is only present, and therefore it will be less stable. Okay, and due to this, the anion will be less stable, and therefore this compound, that is benzyl alcohol, will be less acidic. I hope you understood this. Next, we know that these are acids and this is phenol. So in this, obviously phenol will be less stable. Sorry, less acidic. Okay, but how? See, when we compare these two, here the anion form can go in resonance directly in the benzene ring. That means here resonance is present. Okay, so therefore this anion is stabilized by resonance. This was not present in this. Therefore, this phenoxide is more. This phenoxide anion is more stable than this compound, and therefore in these two, this is more acidic. Okay, but you know these two are carboxylic acid. I am saying this again and again. If these two are carboxylic acids, then with comparison to phenol group and alcohol group, acid will be always higher acidic, obviously, because it is acidic, right? So these two are at least. Then when we are comparing these two groups, see here COH is group present, here carboxylic acid group is present, here also same, but the point of difference is this electron withdrawing group, which will stabilize this negative charge. Okay, so this Cl electron withdrawing group is present at para position, means resonance is possible, because we know at para position and ortho position resonance is seen. Therefore, in this case, this negative charge will be stabilized by this, because this chlorine will pull electron density, making this anion stable. So here this effect is possible. Therefore, this will be more stable. This anion will be more stable as compared to this anion. Therefore, as this is more stable anion, that means it is more acidic. So when we compare A and B, A will be less acidic than B. So this will be the final order of acidic strength. So whenever there are different functional groups, you have to consider the acidity of functional groups first, and then try for stability of anions. Okay. Now let's go for the next question. Here we have to compare the acidic strengths of orthonitrobenzoic acid and para-methylbenzoic acid. Okay, so it is the easiest question, I think, for we have solved the questions. See here, when we remove, this is acidic hydrogen, when we remove the acidic H plus, what will we get? We will get this anion and this NO2 group at ortho position. Similarly, when we remove this H plus from here, we are again getting this anion, and we have this group at this position. So we know simply this is electron withdrawing group. How it withdraws electrons, I have uploaded video already. In short, you can go and check. Okay. So in this case, NO2 is electron withdrawing groups, means it will withdraw electrons, and therefore this charge will be stabilized. Okay, this charge will be stabilized. But in case of this compound here, CH3 group is electron donating group. And whenever there is negative charge present and electron donating group is present, that negative charge gets destabilized. Okay, destabilized. Therefore, this compound is not stable. And if this anion is not stable, it will not lose H plus easily. Therefore, in this case, when you compare the acidic strength of both the compounds, the stabilized anion is more favorable. Therefore, the first compound, that is compound A, will be more acidic and B will be less acidic. So I hope you understood this. Acidic strength will be A will be more acidic than B. Okay. In next question, see why benzoic acid dissolves in sodium bicarbonate but phenol does not. So simply this is question. This question is also on acidic strength, but it is in somewhat different words. Okay. See here what is asked. First of all, we have given sodium bicarbonate. So you should know the structure of sodium bicarbonate. So what is sodium bicarbonate? This NaSCO3. Okay. So when we draw the structure of this, so its structure is like this. This is oxygen. Here H and here N. O minus Na plus. Okay. So this is the structure of sodium bicarbonate. So which is the weakest bond here? Weakest bond is this. O minus Na plus. Okay. So now in this case, see, we have to see the benzoic acid is dissolvable in sodium bicarbonate and in this compound, but phenol is not. So what is benzoic acid? Benzoic acid is this. This is benzoic acid and phenol is this. See, when we have to react these two compounds, we know that when this compound will react with this compound, this H plus will be donated here and this O minus, because this bond is very weak. This O and Na bond is very weak. Therefore, what will happen? This oxygen will attack on this hydrogen and we will get an ion here. Okay. So, when it is possible, when this compound is more highly stronger acid, then it can give its H to there and therefore we can get a more easily dissolved. When this bond is breaking, this will be dissolved. Okay. So, when will this happen? This will happen when this compound donates this H plus easily and forms the anion. So, this is possible in this case. But here what's happening? Here that phenol is least acidic. We have already compared them. So, this phenol is less acidic than this because here as benzoic acid is stronger acid. Therefore, what will happen? This benzoic acid will easily dissolve in this compound because sodium bicarbonate is a weak base. So, therefore, if it is weak, we need a strong acid to react. Therefore, benzoic acid being a stronger acid. Why stronger acid? Because it can easily lose as H plus and we will get a stronger anion. And in case of phenol, anion is stable, but it is not stronger than this. It is a weak base. Weak acid. Therefore, what will happen? Benzoic acid being the stronger acid, it will easily dissolve in NaSCO3, but phenol cannot dissolve in NaS. I hope you understood this question. So, our next question is, we have to compare the acidic strengths of these compounds. So, first is orthomethylphenol. This is just, you know that it's what is common means. Its common name is ocresol. Then benzoic acid and benzyl alcohol. Simply, I have already told you all functional groups are different. So, I think it will be very easier for you. Okay. What will happen here? This is orthocresol, which is alcohol, or we can say phenol, but substituted phenol. And in this case, it is a benzyl alcohol. In this case, it is a acid. So, we know that acid will be always high, means strength of acid will be always highest, then phenol and then alcohol. Okay. So, depending on this order also we can say the stability, or we can, when we remove the H plus, we can check the stability of anion form. So, see here, this anion will be formed. In this case, this anion will be formed, and in this case, we will get this anion. So, we know that in this case, here only inductive effect is present and that inductive effect is donating. Therefore, this will be destabilized. Okay. Therefore, it will be least acidic. Means acidic strength will be C will be least acidic. And when comparing these two, here O minus is formed, which will be stabilized by resonance effect. But here electron donating group is present, which will destabilize this anion by inductive effect. Therefore, it will come at second position. But here resonance is also present, and due to this, in A and C, A will be little more slightly more stable. Therefore, it will come in second position. And at last, here only resonance effect is present, which is stabilizing the compound. Therefore, B will be most acidic. Okay. And the last question of this series is acidic strength of phenol, orthonitrophenol, metanitrophenol, and paranitrophenol. Okay. So, this is a lengthy explanation. I will explain it in next lecture. Till then, you try to solve this and then check whether your answer was right or wrong. Okay. Thank you very much.